Here we go for the solving quadratics test review. Just to briefly here explain here right at the start, I'm going to do several different versions of the multiple choice questions just to make sure you guys are seeing a couple different things that might happen with that, or just different extra examples. And then also we'll do a few of the free response, but really the free response are going to be just like the multiple choice. Also talk a little bit about what we want you to explain if possible and show your work. So that hopefully we do the best we can on this test. But the main thing is that our understanding, we understand kind of the concepts of what we're trying to accomplish here with everything. All right, so let's get right to it. So number one is simplifying radicals. So we're looking for matches. So you can pick whichever numbers right off the top of your head. Like this one ends in a 0, so I'm going to go with 22 times 10, right? And then we're looking for matches from there. So here for 22, I've got 11 times 2. For 10, I've got 2 times 5. So I've got a pair of 2's. So that comes out, and then under the radical, I still have 11 and a 5. So it'd be 11 times 5 is 55. So there is that one. Okay, and then I'll show you a couple other ones to go with it. I'm going to go pretty quick here, so pause. I just don't want this video to end up, half hour, 45 minutes. So I'm going to try to keep moving. For 300, it ends in, anything that ends in 100, I'm going to use 100 itself, 100 times 3. Well, actually, sorry, we can just put this all under one radical, just to keep it easier. 100 times 3, and then 100 actually is a perfect square, so I can keep that as 10 times 10 times 3. So now I've got a pair of 10's, so that's going to become 10, and then the leftover radical 3 goes right there. So that's that one. And then for 63, I'm going to go and use, you can use 21 and 3, but I'm going to use 9 times 7. That way I can go with the 3's, and you would get this. The thing about doing it this way is that no matter which factors you decide to start with, you should end up with the same pair at the end. So here we end up with 3 radical 7. So there you go. There are 3 examples with simplifying radicals. Okay? So we'll keep moving here to number 2. This one is combining. This is basically combining like terms. 9 radical 5 minus 3 radical 5. That was one example. We had 3 radical 11 plus 7 radical 11. And I know on your review, I know you all had one of these. These were shuffled around. So some of you might have had this one, some of you might have had that one. I'm just going to show them all. That way you see some extra examples anyways to hopefully help your understanding. Let's see, 12 radical 13 minus 8 radical 13 and 3 radical 7 plus 5 radical 7. All right, so as long as these are common radicals, we can just do 9 minus 3, just like we would if we did 9x minus 3x. That would be 6x. This is going to be 6 radical 5. Okay, so that was that one. If you had this one, or just for your understanding, they're both radical 11s. So 3 plus the 7 is 10, radical 11. So there's that one. So this is probably the fastest one on the test. Radicals here, we've got 13, so 12 minus the 8 is 4, and then this is like a label, radical 13, that goes there. Okay, and then one more here just to really drive the point home, hopefully. We got radical 7s this time. 3 plus 5 is 8, radical 7. So there you go. That was the second one. That was combining like radicals, basically, combining with the same label. All right, so that was number 2. Let's keep moving to number 3. This one was multiplying radicals. So we had 4 radical 11 times 5 radical 2, or some of you might have had 2 radical 5 times 3 radical 7. So whichever one you had, it's the same process either way. So the parts that are outside the radical, like the 4 times the 5, that's 20. And then under the radical, just like I did when I was simplifying earlier, we could think of these, 11 times 2 is 22. Now, 11 and 2 are actually both prime numbers. There's no matches. So that's it. That's my answer here on number 3. Now, if I could simplify this, I would want to, but 22 you can't. Similar happens over here. 2 times the 3 is 6. Under the radical, we got 5 and 7. There's no matches. They're both prime. So we get 35, and that's it. 6 radical 35. That's my answer if you had that example. Okay? So there you go, there's a couple of those. All right, and keep moving here. Number 4. This one, we finally get to solve some quadratics here. X squared plus 4x plus 4 is equal to 0. Or you might have had x squared plus 6x minus 16 equals 0. All right, so we have a trinomial. So when we're factoring, we can multiply a times c. Now the good news is we can take the shortcut here. We don't have to do factor by grouping, but we're going to look at factors of 4, 1 and 4, or 2 and 2. Which one will combine to 4? It's definitely this one. So they're all positive, so those both stay positive. So we got x plus 2 times x plus 2 is equal to 0. All right, so we got to think what will make this one 0, what will make that one 0. So this one actually ends up being only one solution, because this one, think of it this way. If you want to write this out, you can, or basically you set it equal to 0, because if this is 0 times anything, it doesn't matter what this would be. We get the negative 2 plugged in here, plus 2, that's 0, and 0 times anything is that. Now, this one's unique because it's actually x plus 2 times x plus 2, so what would make this one 0 is the same, so that one has actually one solution. So a lot of times we get 2 solutions. There's an example where we only get 1. All right, this one over here, we will get 2 solutions, so here we go. We got factors of negative 16. You got 1 and 16, 2 and 8, 3 doesn't work, 4 and 4. All right, so which of those will combine to 6 by subtraction? That would be the 2 and the 8. Okay. And then, let's see, so it's positive 6, so the larger one's going to be positive. This will be a negative 2. So our factors will be x minus 2 times x plus 8 equals 0. Now again, we could set it up and go through the work, but really, what's going to make the 0 is just the opposite of this sign. So positive 2, or this case would be a negative 8. So there you go. We could have looked at that with this one. What will make this one 0 is the negative 2. All right, so there's a couple solved by factoring. Now you will have to do that again on the free response. I'm not going to do the free response in this video just so it doesn't end up being, like I said, 45 minutes long. But there's 2 examples just like the free response. So you would want to show this work in the free response section. Okay, so there's number 4. All right, let's go to number 5, which is complete the square. So we got x squared plus 6x, fill in the blank, equals 27. So this would be one completing the square. Whoops, I'm going to need some of that space there. So, all right, so b is 6, right? So we have to start there. So b is 6, we take half, and then we square it. So half of 6 is 3, and then 3 squared is 9. So you want to put that in your notes. You get easy notes on the test. Whoops. These are what, like when I was in school, like I said, I think I said this on the notes before, these are the 3 amigos. You can remember as 3 musketeers, 3 little bears, whatever it is you want to call 3 of them. But anyhow, we've already used the 6. Now the 9 is going to go and fill in the blank. So now we've used that. So what factors, so basically we're going to factor this now, and the whole reason we call it complete the square is because this is a perfect square trinomial. So this should always be your factor, because this would be x plus 3 times x plus 3, because 3 times 3 is 9, and 3 plus 3 is the 6. So that's equal to 36. Now you can actually, even on the test, you could skip this step and just, it's always going to be this one squared equals that number. So, and this is what we want. We need to write it as x plus 3 squared, because now to undo something squared, we take the square root. So we get x plus 3 is equal to 6. And whenever you do that, keep in mind, anytime you bring the radical in, you have to account for plus and minus 6. So we subtract the 3, and we get x equals, that's a positive 6 minus 3, or a negative 6 minus 3, because plus and minus is really 2 numbers. So our answer here ends up x equals 3, or negative 9. So there's a complete the square, and this was a multiple choice question. However, free response, you probably have one multiple choice and one free response. So there you go. So I'm going to do one more on number 5. This was like the multiple choice. This was the other one. Some of you maybe had this version. For this one, we'll go a little faster, but just to see the process again, x squared plus 4x equals 5. So I like to fill in the blanks there. Remember, we want b, take half and square it. So b is 4, take half, and then 2 squared is 4 again. So there's my 3 amigos. Add 4 to both sides. That's this one. We already used this one to get started. So this is what should be in here squared. So x plus 2 squared. If this were -2 or this were -4, make sure you put a -2 there if that were the case. But this is all positives. So we get equals 9. To undo something squared, we take the square root of both sides. X plus 2 equals plus and minus 3. We're going to subtract 2 because, well, 9 was a perfect square. That's why that works. If this is not a perfect square, you're just going to write it, you know, -2 plus and minus radical 10 or whatever it might be. But in this case, it was a perfect square. So we get x equals a positive 3 minus 2 or a negative 3 minus 2. So my two solutions here are 1 or -5. There we go. And you can certainly get this sometimes where you don't get a perfect square there, and then you'll have a radical as part of your answer. All right. So there's a review of complete the square. All right, and make sure when you get to the free response and if you show your work, that's going to count as an explanation. Or if you know how to do it, you can do it. I would do it on separate paper before you try to type it in for the test. Okay. All right, here we go. Number 6. Number 6 is a quadratic formula question. 3x squared minus 19x plus 40 equals 0. All right, so we need to know what A, B, and C are. And I've had this looming up here in the top right corner. That is the quadratic formula. This will work on solving anything that is a quadratic, hence the quadratic formula. However, we have to know what A, B, and C are. So I've already labeled them here. We're going to plug them in. It's basically substitution. And then we've got to see, is it going to work? We've got to be careful with simplifying. So x equals, I like to call it the opposite of b because negative 19 is a positive 19. So essentially it's always going to be the opposite sign from whatever it is here. And then b squared minus 4a times c. So 3 times 40, that whole thing over 2a, which is 3. Okay, now this one in particular is tough because you're going to want to use your calculator, which I should have had ready to go right there. So we're going to rewrite this as 19 plus and minus the square root. Now, negative 19 squared, so use your calculator. We get 361. Now, this one, we get -4 times these, right? And so -4 times 3 is -12. You can take that times 40, you just work it out on your calculator, and we get minus 480, I believe, over 6. Okay? Now in this particular case, we keep going, so 19 plus and minus the square root. Now we get a negative 119 over 6. Now in some cases, you might just be done. However, we can't take the square root of a negative, so because of that, this one is no real solution. Okay? If this were a positive 119, we could just circle this because we can't simplify the square root of 119. Okay? All right, so there is a quadratic formula question where we get no real solution. We're going to do one more of those at the end just to wrap things up here in a minute. After we talk about solving by square roots. Now, solving by square roots, number 7, this is the fastest one. These are the fastest ones on solving quadratics. Okay, 2x squared minus 32 equals 0. Now, if you were going to try the quadratic formula, this would be A, this would not be B. B is whatever is next to the variable. So this actually is the constant. This would be C, and B would be 0 if you were going to try that. Now, I wouldn't try that. That's going to take a lot more work than what I'm going to show you here in a second, but I wanted to point that out. All right, so we want to get x squared by itself, so we're going to add 50 in this particular example. We get 2x squared equals 50. We're going to divide by 2, and that gets us x squared equals 25. So once we get to here, to undo something squared, we're going to take the square root of both sides, and we get x equals 5. However, we brought the radical in, so you have to count for plus or minus 5. Now this sign, plus or minus 5, it's the same as writing x equals 5 or negative 5. Okay, these two things mean the same thing. All right, so there's one example. Let's go ahead and do another one. We add 32. Again, we're trying to get x squared by itself. 2x squared equals 32. We divide by 2. And so x squared equals 16. So once again, just like over here, to undo something squared, we take the square root. So x equals plus n minus 4 because we brought the radical into the question. All right, so there is solving by square roots. You'll have one multiple choice and one free response of those where you want to show your work. Okay? All right, last thing. I know there's other free response I'm not going to get to in this video, but hopefully we did some stuff just like it. Want to do number 11, and then I'll talk briefly about number 12. So number 11 is another quadratic formula. I want to do one that's not no solution type answer. Plus x minus 14 equals 0. So again, this is A. Now B in this case is a 1, and C is that, negative 14. Okay, so there's A, B, and C. So B is the one with the variable just x. A is the one that's out front with x squared. So here we go. We go x equals opposite of B, so negative 1 this time, plus and minus b squared minus 4a times c. So 2 and negative 14. So really, I know I'm going quick here, but that's all I did was substitute these. I labeled A, B, and C, and I'm plugging them into the spot where they go with the formula. And you'll be given that formula at the top of the test. You can use your notes. You should have it for the test. Over 2 times a, which is 2. So don't forget that little piece at the end. All right, so now we got to be careful and simplify things. So negative 1 plus and minus. 1 squared is 1. So we multiply all this out. I believe on this one, let's see, we've got 112. Now negative times a negative makes it a positive 112. And you just use your calculator for that. Over 4. Now this one works out nice at the end. And it looks kind of ugly, but it's nice because negative 1 plus and minus the square root of 113. We actually can't do anything with that, so we just get a stop. That's our answer. So if this were a perfect square, like the square root of 100, then you'd have to keep simplifying a little bit more, but there we just get to be done. Okay? So there is number 11. The last thing I wanted to talk about was number 12, where you had the 3 people. You had Tony, Amber, and Paul. You had to decide which one was correct. So on that, you just basically do it on your own and then go through and check who is correct. So Tony, you would need to say Tony's wrong because he didn't change the signs, right? Whenever he solved by factoring, he didn't change the signs at the end. Amber was wrong because when she factored in completing the square, it should have been x minus 7 squared. So you need to say that so you can get full credit. And then Paul was correct. Okay, so anybody who's correct, you get to get away without having to give too much explanation, but you don't want to say the wrong person's correct. So make sure you go through and check those. All right, we're getting up to almost 20 minutes here, so I'm going to wrap this one up. If you have questions, please send me a Canvas message. And best of luck on the test. Do the best you can. And hope you guys are all doing all right. So thanks and good luck.